Okay, so in section 5.2, let's move on to 5.2. We're going to talk about direct variation. Okay, so the first idea that we're going to explore is what the heck direct variation is. Have you guys ever heard of direct variation before? You've heard of it? Kind of heard of it? Okay. All right. All right. So here's what we're going to do. We're gonna play a little bit, all right? So I'm going to write down a couple of equations. So I'm going to write down 3x. Okay. Yeah. Well, all you have to do is watch for right now. Okay. Okay. There's 3. Okay. There's 3. Okay. So right now I'm going to write down a couple of equations here. Write down negative 5x. Okay. I'm going to write down another one. Y equals negative 11 halves x. Put that one on there as well. I'll move this over a little bit so we can see. And I'll write down y equals negative 6x. Like that. And y equals 5x. Like that. And y equals 2/3 x. Put that one on there. Okay, so check this out. I have a bunch of lines here, right? I have a bunch of lines. These are examples of direct variation. These are examples of direct variation. Let's go ahead and write that in there. These are all direct variation. Why? What do they all have in common? They all pass a certain point. They all pass through the origin, right? They all have direct variation. So, direct variation is a linear graph, right? It's a line, but it's a very special type of line. It's a line that passes through a certain location. And that location, of course, is the origin, right? So 0, 0. So you can kind of see through all of these, no matter if we zoom in, they all pass through the origin. That's our direct variation. So for our definition then, direct variation is going to be this. It's going to be the form of any line that's in the form y is equal to kx. Y is equal to kx. And the k is what's known as the constant. The constant of variation. Okay? So every single graph, right, and that we just noticed must pass through what point? Must pass through the point 0, 0, as we see in all of these graphs right here. Okay? So let's check this out. If I gave you, let's go back to the right mode. Let's go back to math mode. If I gave you, y equals 3x, and put that on the graph, and I gave you y equals 3x plus 2, and put that one on there. Okay? So which one of those represents direct variation? Y equals 3x. How come? Passes through the origin. Okay, now what is the constant of variation? The 3. Yeah, the actual 3, right? So the constant of variation is the same thing as the what? As a slope. Yeah, it's the exact same thing as a slope. Notice that both of these lines have the exact same slope, which is 3, but because y equals 3x passes through the origin, we have a direct variation, versus the other one, which was where we don't have a direct variation. So y varies directly with x, meaning there is a direct correlation between x and y and the relationship between the two. Alright, I have 2 equations here. Okay? And the question that we're trying to answer is, do they represent direct variation, yes or no? And if they do, what is the constant of variation? So the first thing that we want to try and do to answer this question is we want to get it into the form y equals kx. That's what we're trying to get it to do. So we should solve both of these for y. So on the left-hand side here, I have 7y equals 2x. I'm going to divide both sides by 7. So I get this. I get y is equal to 2/7 x. All right? Does that look like this right here? Does that look like direct variation? Yes or no? Yeah, it sure does, right? It has the exact same form, okay? So we're going to say that this one is yes. And what is the constant of variation? It's 2/7, right? The constant of variation is 2/7, okay? All right, so let's look at that. We're going to graph 7y equals 2x, okay? What does that actually look like for us? If I graph 7y is equal to 2x, I graph this over here. Here's what it looks like. So can you guys tell me where you think where does the constant 2/7, where does that play a role into the picture of the graph? The constant 2/7.
The slope.
Yeah, the slope, right? Exactly, from the slope. But notice I can always start from the origin, right? So if I go up 2 and I go over 7, 1, 2, 3, 4, 5, 6, 7, I am guaranteed to hit another point on the graph right there. So there's my constant of direct variation as measured from the origin because it represents direct variation. Pretty sweet, right? Okay, what about this one over here? What about this one, part B? Well, I want to solve for y, right? So I'm going to get 3y is equal to negative 4x plus 8. So if I divide by 3 everywhere, divide by 3, I get y is equal to negative 4/3 x plus 8/3. Does that represent direct variation? No, it does not. How come? What's different about it?
It has plus 8.
Yeah, it has the plus 8/3 in the end. So because of this right here, because of that extra constant I'm adding on the end there, it does not represent direct variation, so that one does not. Okay?
Could you zoom out a little bit?
Yeah. Yeah. Is that what you need? Okay. So in this example box number 3, they're going to tell you that y varies directly with x. So when you hear that language, y varies directly with x, that means that you have direct variation, so y equals kx. Okay, and then they'll say y is 35 when x is equal to 5, and it will say what direct variation equation relates the two together. Okay, so here's what we do. This is how you solve this thing, right? So we know that y varies directly with x. So I know that I have y is equal to kx. I know that that holds true because I was told in the directions that y varies directly with x. Okay, so far so good. Now what else do I know? I know that y is 35 when x is 5. So 35, I can replace, substitute in, is equal to the constant when x is equal to 5. Okay? So 35 is equal to k times 5. So I can easily now isolate the k by dividing both sides by 5. And what's 35 divided by 5?
7.
So 7 is equal to k. So my constant of variation is 7, and the direct variation that I could write down is y is equal to 7x. Does that make sense?
Yes.
Okay, now it'll also say something like, okay, what is the value of y when x is 9? Alright, so what's the value of y when x is 9? Well, we just substitute in, right? 7 times 9, how much is that worth? 63. So the value would be 63 for us, for that one. Okay? Okay, so check this out. This is another type of example problem that we can do for direct variation. You may be given a table of data points, alright? And they may ask you, does the table or the data point represent direct variation or not? Yes or no, how can you tell? Alright, so how would we figure that part out? Anyone got any ideas? Okay, yeah, let's start with the formula. We know this. We know that y is equal to kx. So far, so good. Everybody knows that part? So that means if I divide x on both sides, I get the constant has to be y divided by x. Is that true? So here's what we do. We take every y, every ordered pair, and we divide it by x, and we make sure that it's the same for each of them. So as an example, here's my first ordered pair, 4, 6. So I'm going to take 6 and divide it by 4. I'm going to take the y and divide it by the x. Okay, how much is 6 divided by 4 in simplest terms? What would it be? It is 3 halves, right? Okay, good. Now let's take 8, or let's take 12 and divide it by 8. Okay, here's 12 divided by 8. How much is that in simplest terms? 3 over 2 again. Okay, let's take 15 divided by 10. Okay, 15 divided by 10. How much is that in simplest terms? 3 over 2. Okay, are all of these the same? Yes, they are all the same. Therefore, my k is constant at 3 halves. So this one is a yes. It definitely does represent direct variation. Right? So far, so good? Okay, now let's try that same idea with this one over here. Okay, so let's take this. Let's take 3.2 and divide it by -2. Well, that's pretty much in simplest form right there. Let's take this one. Look at this. Let's take 2.4 and divide it by 1. Is there any way that these are the same? No, those are definitely not the same. One of them is negative, one of them is positive, right? So that's definitely not the same for me. So I know that this is not direct variation.